Welcome to Math with Mrs. Bibb. Today we will be discussing operations with polynomials. I took the time today during my planning to write down all of these definitions. I will read those as slowly as I can, but if you would prefer to pause, write them down, and then fast forward, you're perfectly okay to do that. I may say a couple things that you want to hear, but otherwise it would be okay. A polynomial is a monomial or the sum of two or more monomials. And I would like to add, and you don't have to write it down, that the sum of two or more monomials, those would be unlike terms. There are three types of polynomials, specific polynomials: monomial, binomial, and trinomial. I wanted to make sure to point out that a monomial is one term, no addition or subtraction signs. A binomial is two terms, only one addition or subtraction sign. And then a trinomial is three terms, two or more addition or subtraction signs. A monomial is a number, a variable, or a product of a number and one or more variables. I wrote down some examples so you could see. X is a monomial. M to the fourth power is a monomial. 3n is a monomial. 5xy squared, that's a monomial. And negative 10a squared, b cubed, c. Those are all monomials. You'll see no addition or subtraction sign within those terms. For binomial, it's the sum of two monomials. For example, x plus 3. X is a monomial, 3 is a monomial. You put a plus sign in the middle, that makes a binomial. 8mn squared minus 2. Monomial, monomial, put them together, they're a binomial. And then for three terms, two plus or minus signs we already said, it's the sum of three monomials. For example, x squared plus 4x minus 2, or 5x squared y plus 2x minus 4y. Those are all examples of trinomials. I forgot to include degree of a monomial and degree of a polynomial, so if you'll try to squeeze those in. The degree of a monomial is the sum of the exponents of all the variables. The degree of a polynomial is the greatest degree of any term of the polynomial. I wanted to add also how operations affect the exponents of polynomials. This is very important to know. When you're using addition or subtraction, you leave your exponents alone. 5x plus 4x is 9x. It doesn't change. 10x minus 5x is 5x. That doesn't change. When you're multiplying like bases, you add your exponents. 5x times 4x is 20x squared because 1 plus 1 is 2. 10x squared times negative 5x is negative 50x to the third. And then when you're dividing, you subtract exponents. 9x cubed divided by 3x, you divide 9 and 3, that's where you get 3. And then 3 minus 1 is 2. Same thing here, 9 divided by 3 is 3. My exponent is larger in the denominator, so I subtract from there. 2 minus 1 is 1. We are going to perform the indicated operations. I know that this sheet I actually gave you, it ends with number 4 on the front, and then when you flip it over on the back, it's just completely blank. So if you'll do the other examples that I have that are 5 through, I think it's 13, on the back side. So it says perform the indicated operations. This tells me to add like terms. 3x squared and 2x squared are like terms. 9x and 4x are like terms. 27 and negative 12 are like terms. So I'm going to combine 3x squared and 2x squared. That gives me 5x squared. I'm going to combine 9x and 4x. That gives me plus 13x. And then I need one more color. 27 plus negative 12 is positive 15. And this would be my answer. And I'll go back in just a minute and do what it says in pink underneath there. Now, this says to subtract. I have found for most students it's easier for them to distribute this negative and add. So I'm going to make that plus, and then a negative times a positive is a negative. A negative times a negative is a positive. A negative times a positive is a negative. Oh, let me get rid of that. A negative 14. Now let's combine like terms. And I'm going to put this in descending order, or standard form is the way the book calls it. I'm going to put my largest exponent first. 3x squared does not have a like term, so it will go first. Minus 7x goes with positive x to give me minus 6x. And then negative 14 goes with positive 2 to give me negative 12. That's my answer to adding or subtracting those two polynomials. Now I'm going to distribute. Negative 2x times 4x squared is negative 8x to the third power. Negative 2x times 3x gives me negative 6x to the second power. Negative 2x times negative 5 gives me positive 10x. And that would be my answer to those questions. For the next one, I'm going to distribute, and then I'm going to combine like terms. I'm going to distribute the 3n, and that's just those two things, and the negative 2. 3n times 6n is 18n to the fourth. 3n times negative 4n is negative 12n squared. Negative 2 times 9n to the fourth is negative 18n to the fourth. And then negative 2 times negative 11 is positive 22. Now when I combine like terms, those go away, and I'm left with negative 12n squared plus 22. That would be the answer to that question. I want to do what it says at the bottom. I want to name the degree and what type of polynomial each of these are. As I look at this one, and this one, there are 3 terms separated by 2 signs, so those are trinomials. The last one, number 4, has two terms, so it's a binomial. And now I'm going to go back, and I'm going to name the degree for each of the polynomials. So the degree tells me the degree of a polynomial is the degree of the highest degree of the monomials. The degree of this is 2, the degree of this is 1, the degree of this is 0. So 2 is my degree for number 1. Now for number 2, that is a trinomial also, and the degree of this term is 2, the degree of this term is 1, the degree of this one is 0 since there's not a variable, so 2 would be the degree for that one. For the next one, the degree of negative 8x cubed is 3, the degree of negative 6x squared is 2, the degree of plus 10x is 1, and the largest number is 3. And then for the last one, the degree of negative 12n squared is 2, and the degree of 22 is 0, so the degree is 2. And this would be the largest degree. For the next one, I'm going to multiply. Please do write down the definition. Quadratic expression is an expression in one variable with a degree of 2. So our largest exponent will be 2 for question 5 and 6. And the book explains several ways to do this, and I really just want you to use one way, and that is to distribute. So we're going to multiply x times x plus 6. Then I'm going to multiply negative 2 times x plus 6. So x times x plus 6. Then I'm going to do negative 2 times x plus 6, and then combine like terms. X times x is x squared, x times 6 is 6x. Negative 2 times x is negative 2x, negative 2x times 6 is negative 12. And then put together like terms, x squared plus 4x minus 12 is the answer to those two binomials being multiplied. And then for number 6, I am going to multiply 3x with 4x minus 10 and negative 4 times 4x minus 10. So 3x times 4x minus 10 and negative 4 times 4x minus 10. 3x times 4x is 12x squared. 3x times negative 10 is negative 30x. Negative 4 times 4x is negative 16x. Negative 4 times 10, negative 4 times negative 10 is positive 40. Combine like terms. Nothing to go with 12x squared. This would be negative 46x plus 40. That is my answer. Moving on to the next one. I'm going to multiply, for this next one, a binomial times a trinomial. I do not do it any differently. I multiply the first term times the trinomial and the second term times the trinomial. So 2x times the quantity x squared minus 3x minus 4, and then positive 1 times the quantity x squared minus 3x minus 4. So that would be 2x cubed minus 6x squared minus 8x plus x squared plus, minus 3x minus 4. And then combine like terms. Nothing to go with 2x cubed, so 2x cubed goes first. Negative 6x squared and x squared is negative 5x squared. And then I have minus 8x with minus 3x, that's minus 11x. And then minus 4. That is the solution to that problem. Number 8, I'm going to multiply a trinomial times a trinomial. So I'm going to multiply first term times all of that. Then I'm going to multiply the second term times all of that. And then I'm going to multiply that one times all of that. And now, can you really tell the difference? Oh yeah, I see the red in there just a little bit. Red times red, so m squared times m squared plus 7m minus 3. Blue times blue, minus 5m times m squared plus 7m minus 3. Then positive 4 times m squared plus 7m minus 3. Looks like a 5 on that second one. Wonder if I did say 5. Okay, let's distribute. M squared times m squared is m to the 4th. M squared times 7 is 7m cubed. M squared times negative 3 is negative 3m squared. Negative 5m times m squared is negative 5m cubed. Negative 5m times 7m is negative 35m squared. And then negative 5m times negative 3 is positive 15m. Now to read my little scribble I have over here, I'll try very carefully. 4 times m squared is positive 4m squared. 4 times 7n is positive 28m. And 4 times negative 3 is negative 12. Now let's combine like terms. Nothing to go with m to the 4th. 7m cubed, negative 5m cubed. I think that's it. Would be positive 2m cubed. Then negative 3m squared, negative 35m squared, positive 4m squared. That would be negative 38 plus 4, negative 34m squared. Okay, now I'm down to just m. I've got 15m and 28m. And that's going to be 43m plus 43m. And then I have minus 12. So hopefully that's correct. If not, if I made a silly mistake, let me know. But I think that's the right answer. Moving on to number 9. Now, both of these students tend to miss. Please know you are not, air quotes, distributing 3x plus 2. You are actually multiplying 3x plus 2 times itself. So you're going to multiply 3x times 3x plus 2 and positive 2 times 3x plus 2. So 3x times 3x plus 2 plus 2 times 3x plus 2. And we get 9x squared plus 6x plus 6x plus 4. And we get 9x squared plus 12x plus 4 is the answer to that one. For the last one, this means I'm going to multiply that by itself 3 times, 5g plus 2h times 5g plus 2h times 5g plus 2h. Now, what I'm going to do, I'm going to bring this one down, 5g plus 2h. I'm going to multiply 5g times 5g plus 2h, and then I'm going to multiply positive 2h times 5g plus 2h. That's what I'm going to do. So 5g times 5g plus 2h plus 2h times 5g plus 2h. I'm going to distribute 5g plus 2h. Now I will distribute inside the parentheses. I'm going to distribute here and distribute here. So I would have 25g squared plus 10gh plus 10gh plus 2h squared. I'm going to take away the brackets there. I'm going to go ahead and combine like terms and take those away. So I'm going to have 25g squared. I see I have too many h's right here. Oops. Plus 20gh plus 2h squared. And that's wrong. Hopefully you all caught that. That should be plus 4h squared. Glad I saw it. So plus 4h squared. Now I am going to multiply, grab my highlighter, I'm going to multiply 5g times this trinomial and then plus 2h times this trinomial. So that's what I'm going to write out. 5g times 25g squared plus 20gh plus 4h squared. Then the red plus 2h times 25g squared plus 20gh plus 4h squared. Then I'm going to distribute 5g times 25g squared is 125g to the third. 5g times 20gh is plus 100g squared h. And then 5 times 5gh squared is positive 20gh squared. The next one, plus 50g squared h plus 40gh squared plus 8h cubed plus 8h cubed. Now let's combine like terms. There's nothing to go with 125g to the third. 100g squared h plus 50g squared h is 150g squared h. And then 20gh squared plus 40gh squared is 60gh squared. That's tongue twister. 60gh squared plus 8h cubed. I hope that's the right answer. I think it is. Moving on to the next one. For this next one, this is a special product. It's under the section for special products, but you'll see what happens, that what makes it special. So I'm going to multiply x times x plus 7 and negative 7 times x plus 7. So x times x plus 7, and then minus 7 times x plus 7. That's going to be x squared plus 7x minus 7x minus 49. Then combine my like terms. That makes 0, so my answer is x squared minus 49. That's the answer to the quantity x minus 7 times the quantity x plus 7. Now, 12 and 13 are division problems, and so remember, when you're dividing, you subtract your exponents. The first thing I want you to do after you write down the original problem is rewrite it as a division problem of two separate terms. So 5x squared divided by 5x minus 15x divided by 5x. 5 divided by 5 is 1. X squared divided by x is x in the numerator because 2 minus 1 is 1. And then minus, the x's cancel out. What's 15 divided by 5? 3. So the answer is x minus 3. For the next one, I'm going to rewrite just like it says. I'm going to rewrite this as 24 h to the fourth k to the third divided by 4hk plus 12 h to the third k to the second divided by 4hk minus 4hk divided by 4hk. So that would give me 24 divided by 4 is 6. H to the fourth divided by h is h to the third. 4 minus 1 is 3. K to the third divided by k is k to the second. 12 divided by 4 is positive 3. H to the fourth divided by h is h to the second. And then k squared divided by k is just k. 3h squared k. Then this last one, negative 4 divided by 4 is negative 1. H divided by h cancels out. K divided by k cancels out. So this is my final answer. 6h cubed k squared plus 3h squared k minus 1. I hope that you learned something today and that you have a wonderful evening.